In this video, I'm going to go through the solutions to Unit 2 test. The first question is to simplify the following rational expressions and state the restrictions on the variable. The first one is x squared plus 4x minus 60 divided by 2x plus 30 divided by x squared minus 8 plus 12 over 6x minus 12. The first rational function, the numerator has the leading coefficient 1, so I can use sum and product method. So I can write it as two numbers that multiply to negative 60 and add up to plus 4 are 10 and negative 6. So this becomes x plus 10 times x minus 6 divided by, now taking the 3, the common factor out, I get 3 times x plus 10 divided by, now again the leading coefficient is 1, so I can use sum and product. Two number product is 12, add up to negative 8 or negative 6 and negative 2, so this becomes x minus 6, x minus 2 over, the common factor is 6, so I get 6 x minus 2. Now before I simplify everything, it is obvious that x cannot be negative 10 and 2, so the restrictions are x cannot be 2 and negative 10. Now I can simplify negative x minus 2 here, and x plus 2 and x plus 10 and x plus 10 here. And then also I use the fact that to divide two fractions I'm going to flip and multiply, so I get x minus 6 over 3 times 6 divided by x minus 6, and x cannot be 2 and negative 10. Now before I simplify x minus 6, I'm going to add another restriction, which is 6, because x can't be 6. Now I cross out x minus 6, I get 6 over 3, which is 2, and x cannot be equal to negative 10 and 6. For the second one, I'm going to do the same thing as I did before. So I'm going to write 3 over x squared minus 7x plus 10, two numbers that the product is 10 and add up to negative 7 or negative 5 and negative 10, negative 2. So I can write this one as x minus 5, x minus 2 minus 5x over, and then I can factor out x, so I get x minus 2. Now by looking at the denominators, you can see that x cannot be 5, 2, 0, and 2. So x cannot be 0, 2, and 5. 0 is because of this x, 2 is because of x minus 2, and 5 because of x minus 5. Now what do I have to do is to find a common factor here for the denominator. You can see that both fractions, they have x minus 2, but the fraction on the right has x, so I have to multiply the numerator and the denominator of the second fraction by x minus 5. Since I've already written the restriction x cannot be equal to 0, so I can safely cross out x here. So I multiply the second fraction by x minus 5 and also divided by x minus 5 here. So the common denominator becomes x minus 5 times x minus 2. So the first fraction gives me only 3, and the second fraction gives me negative 5 times x minus 5. and x cannot be 0, 2, and 5. Now if I simplify the numerator, I'm going to get 3 minus 5x plus 25 divided by x minus 5 times x minus 2. Now 3 plus 25 gives me 28 minus 5x over x minus 5, x minus 2, and x cannot be equal to 0, 2, and 5. The next question is to simplify 21x squared y over 14x squared minus y minus 35xy. I'm going to write as 21x squared y over 14x squared y minus 35xy. The common denominator between them is 7xy. So 7xy, if I factor it out, I get 2x from the first term, and then I'm going to get negative 5 from the second term. As you can see, x cannot be equal to 0, y cannot be equal to 0, and x cannot be equal 2x minus 5. If it's 0, then it's 5 over 2. Now I can safely cross out y here, and the exponent here can go with this x. And the 21 over 7 gives me 3. So I'm going to get 3x over 2x minus 5, and x cannot be equal to 0, 5 over 2, and y cannot be equal to 0. The next question says that I have the ordered pair in this relation, which says negative 3, 1, 4, 1, negative 7, negative 7, negative 3, 4, and 3 and 2. State the inverse. As we know, the inverse, we just flip x and y. So this inverse becomes 1 and negative 3, 1 and 4, negative 7 and negative 7, 4 and negative 3, 2 and 3. You just exchange the position of x and y. This means that this becomes your new x and this becomes your new y. The next question is that is this inverse a function? The answer is no, because if we look at these 2 points, you can see that the x value is repeated. This is exactly like if this is my graph, then at x equal to 1, you have negative 3, which is this point, and 4, which is this point, and you can see that it does not pass the vertical line test. So the answer is no. State any invariant points. You can see that the point negative 7 and negative 7 does not change under the inverse. So this means that negative 7 and negative 7 is the invariant point. The next question says, when working with rational expression, why do we need to state restrictions on the variables? First of all, because it is a rational expression, we are dealing with fractions, with the variable in the denominator. So the variable is in a function, let's say f of x, and let's say the numerator is g of x. We know that number divided by 0 is undefined in math, so this means that we have to find the restrictions in f of x that causes the denominator become 0. That's why we have to find all those restrictions. The next question says, do the following two graph y equals square root of 2x plus 10 and y equal to square root of 2x and then plus 10 outside the square root. Do they produce the same graph? One way of explaining that they do not produce the same graph is the following. If I simplify this first one, I get 2 times 2x plus 5. This means that your h value in this equation is negative 5. So we are translating horizontally 5 units to the left. Now if you look at this graph, you can see that your h is equal to 0, your k is equal to 10. This means that the graph is not horizontally translated, but vertically 10 units up. And in this graph, our k value was 0. So they do not produce the same graph. Another way of explaining why these two do not produce the same graph is just to pick a value, let's say x equal to 0. If they produce the same graph, their y value has to be the same. For the first equation, y becomes square root of 2 times 0 plus 10, which is square root of 10. The second graph gives us y is equal to 2 times 0 plus 10, which is 10. And you can see that the y values are not the same. So they do not produce the same graph. The next equation says that you have an object of mass p plus 1 over 3p plus 1, and the density is p squared minus 1 over 9p squared plus 6p plus 1. We are supposed to find the volume, which is given by mass over the density, and state any restrictions on the variables and fully simplify the expression. First of all, if you look at the density, you have a quadratic in the denominator with the leading coefficient not equal to 1. So we have to see how we can factor out the denominator. To do that one, we are going to use the decomposition method. In our case, AC is 9 times 1, which is 9. B is 6. Now we are going to try to find two numbers. The product is 9 and the sum is 6. Now those two numbers are 3 and 3. 3 times 3 is 9, 3 plus 3 is 6. So I can write 9p squared plus 6p plus 1. I can decompose the middle term as 3p plus 3p, and then I can write this one as 9p squared and the constant, which is 1. Now if I take the first two terms, I get 3p as common factor, so I get 3p plus 1 plus 3p plus 1, the last two terms. 3p plus 1 is common, so I get 3p plus 1 times 3p plus 1, which is 3p plus 1 squared. So I can write the volume is mass, which is p plus 1 over 3p plus 1 divided by p squared minus 1 is p minus 1, p plus 1 divided by 3p plus 1 squared. Before I simplify, I'm going to write the restriction. The restrictions are p cannot be negative 1 over 3 because of this term, and the same thing for this one. P cannot be negative 1 over 3. Now I can change division to multiplication, so I can write p plus 1 over 3p plus 1 times 3p plus 1 squared over p minus 1 p plus 1, and again p cannot be negative 1 over 3. Now I introduce two new restrictions here. P cannot be 1 and negative 1. Now I can simplify. I can cross the bottom 3p plus 1 with the numerator, so I'm going to left with 1 3p plus 1 and p plus 1 with p plus 1. So I get v is 3p plus 1 over p minus 1, and p cannot be equal to negative 1 over 3, 1 and negative 1. The next question, we have a base function which is 1 over x. It goes under the following transformations: a vertical stretch by a factor of 4, a horizontal compression by a factor of 1 over 2, a reflection on the y-axis, a translation of 7 units to the left, and a translation of 5 units up. So we are going to apply all these transformations step by step. The first one, it goes under a vertical stretch of 4. So 1 over x becomes 4 over x. Then it goes a horizontal compression by a factor of 1 over 2. Since the factor is 1 over 2, remember that compression is 1 over b. So our b is 2. So this becomes 4 over 2x. A reflection in the y-axis, so we multiply 4 over 2x by negative 1, so it became negative 4 over 2x. Then it says that it goes through a translation of 7 units to the left, so this becomes negative 4, 2x plus 7, because 7 units to the left, and then it goes 5 units up, so this changes to negative 4 over 2 x plus 7, 5 units up plus 5. Now if we simplify this one, we get negative 2 over x plus 7 plus 5. The next question is the base function f of x is square root of x. We have to, part A, we have to sketch this function. To do that one, I'm going to find the table of values for x equal to 0, 1, 4, and 9. If x is equal to 0, y is 0. If x is 1, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Now if I plot this point 0, 0, if x is 1, y is 1, so it's going to be this point. If x is 4, y is 2, which is going to be this point. If x is 9, which is outside the graph, I cannot plot it, so it's going to give me a graph like this one. Now it says sketch the graph of h of x, which is given by negative f of 1 over 2x plus 5 minus 3. To do that one, I'm going to use the mapping notation. From this graph, I can see that a is negative 1 because of negative here. B is equal to 1 over 2. H is negative 5. Remember, the formula is x minus h. And k is negative 3. This means that my mapping notation becomes xy goes to 1x over b, so x over 1 over 2, which becomes 2x, plus h, negative 5, and y becomes ay, negative y, plus k, which is negative 3. So my new table of values becomes, for every x value, I will substitute it back here and find the new value. So when x is 0, we get 2 times 0 is 0 minus 5 is minus 5. When x is 1, we get 2 times 1 is 2 minus 5 is minus 3. when x is 4, we get 2 times 4 is 8 minus 5 is going to give us 3. And when x is 9, 2 times 9 is 18 minus 5 is 13. Now we go for y. We sub it back in this to get the new y value. When y is 0, negative 0 minus 3 is negative 3. When y is 1, negative 1 minus 3 is negative 4. When y is 2, negative 2 minus 3 is negative 5. When y is 3, negative 3 minus 3 is negative 6. Now I'm going to plot these points. When x is negative 5, y is negative 3, which is going to be this point. So this is our reflection of the transformation of the origin, this point. It goes to here. When x is negative 3, y is negative 4, which is going to be this point. When x is 3, y is negative 5, which is going to be this point. And when x is 13, which is going to be off the graph, so we can plot that point, we get a graph which looks like this. Now it says state domain and range of h of x. You can see that our domain is x in R, and x has to be greater than or equal to negative 5. Because of this point, our x goes from this point to the right, and our range is going to be our y value going down here. So our range is y in R, and y has to be less than or equal to negative 3. The next question is to find the inverse of y equal 5 times x plus 3 squared minus 2. To do that one, I'm going to isolate x. So I'm going to move negative 2 to the left, so I get 5 times x plus 3 squared is equal to y plus 2. I divide by 5, I get x plus 3 squared is y plus 2 over 5. Now I take the square root of both sides. I get x plus 3. Square root of y plus 2 over 5 is plus or minus square root of y plus 2 over 5. Now I move 3 to the right. I get x is negative 3 plus or minus square root of y plus 2 over 5. And the last step, to replace x with inverse y and replace y with x. So that's our inverse. The next question is, if the graph of f of x is given here with the vertices at negative 2 and 2, so this is negative 2 and 2 here, 4 and negative 1, which is here, and 6 and 2, which is here. Let's call these points A, B, and C. So this is our point A, this is our point B, and this is our point C. We have a transformation which is 2f of negative 2x plus 8 minus 2. Let's call this transformation G. We are supposed to draw the transform function. Now looking at g of x, I can see that a is equal to 2, b is equal to negative 2, but h is going to be 4. The reason is that I can simplify g of x as 2f of negative 2x minus 4 minus 2. So I can write that h is 4 and k is equal to negative 2. So this means that my mapping notation becomes xy is x over b, which is x over negative 2 plus h, and ay plus k, which is negative 2. So this means that if our table of value is negative 2 and 2, 4 and negative 1, and 6 and 2, remember these negative 2 and 2 is this point, 4 and negative 1 is this point, and 6 and 2 is this point. It's going to be transferred to these new values, x over negative 2 plus 4 and 2y minus 2. When x is negative 2, we get negative 2 over negative 2 is 1, 1 plus 4 is 5. When x is 4, 4 over negative 2 is negative 2 plus 4 is 2. When x is 6, 6 over negative 2 is negative 3 plus 4 is 1. Now I'm going to sub the y values. If y is 2, 2 times 2 is 4 minus 2 is 2. If y is negative 1, negative 1 times 2 is negative 2 minus 2 is negative 4. If y is 2, 2 times 2 is 4 minus 2 is 2. So these are the new coordinates of the point. So 5 and 2. 5 and 2 is going to give us this point. So this becomes A prime, which is the transformation of point A. The next one is 2 and negative 4. 2 and negative 4 becomes this point. So this is going to be my B, becomes B prime. And the last point is 1 and 2, which is going to be this point, which becomes C prime. Now in original graph, A is connected to B, so in the reflected one, A prime is connected to B prime, so it's going to be a line like this one. And in original, B goes to C, so in the reflected one, B prime goes to C prime, which is going to be this. So our new graph is going to be A prime, B prime, and C prime. So the final vertices are 5, 2, 2 and negative 4, and 1 and 2. In the next question, we have two triangles with the same base x. The height of one is 2x plus 4, and the height of the other is 4x plus 6 plus 8. You're supposed to write and simplify an expression that represents the total area of the two triangles. We know that the area is given by base times height divided by 2, so the total area is the sum of the areas. So A is x times 2x plus 4 divided by 2 plus x times 4x plus 8 divided by 2. If we simplify this one, since the denominators are the same, is 2, and the numerator we get 2x squared plus 4x plus 4x squared plus 8x. This is the same as, now 2x squared plus 4x squared is 6x squared plus 4x plus 8x is 12x. Now, the common factor here is 6x, so we get x plus 2 over 2. There is no restriction in the denominator because the denominator doesn't have any variable. But the numerator, because this represents the area, it has to be greater than 0. So this means that 6x has to be greater than 0. So x has to be greater than 0. And also x plus 2 has to be greater than 0. So this means that x has to be greater than negative 2 if I move this one to the right. Now, if you look at the number line, this means x has to be greater than 0. So if this one represents x equal to 0, so everything to the right is the answer. The next one, which is this guy, says x has to be greater than negative 2. You can see that the common region is everything which is x greater than 0. So the answer, the restriction is x has to be greater than 0.